All right, so go ahead and everybody try these 3 questions. You're just analyzing if they are a binomial, it represents a binomial random variable. Yesterday we learned the acronym BINS, okay? In your notes, if you want to just write 1, 2, 3, BINS for each one, check or X. We're just trying to see if this is a binomial random variable. Can you close my door? So BINS, put little check marks by each one. And I'm trying to record for Bennett, so this is. Please start answering these. Oh, did I not give you scissors? They're right here. Thought I did. There you go. Okay, let's, for each question on here, we're going to, you should have written BINS, B-I-N-S, and we are trying to check to see if they, if it does match a binomial setting, okay? So, here we go. Shuffle a deck of cards, turn over the top card, put the card back in the deck, Shuffle again. Repeat this process 10 times. Let X equal the number of aces you observe. Okay? So the first question is it binary? We're going to see B. Is it binary? What do you think about that, Abby?
I said yeah.
Why?
Because either you get an H or you get
Right. Okay. So you get an ace or you don't. All right. Cool. Next, talk about I. I stands for independent. Gianluca, is this independent?
Yes.
How do you know that?
Because you shuffle the same deck over and over again.
You shuffle it. The biggest part is this. You put the card back, right? We talked about that. That was last chapter where this is called with sampling with replacement is independent. So putting the card back, that means it is independent. Okay? So yes, that one's good. All right, good. N, that is set number of trials, Ashanti. Is this good or not? Okay, then how many trials did they say there are? 10 trials. There we go. Good. All right, cool. Is the probability of success the same every single time? Ethan?
Yes.
Yeah, because you're replacing it, it does remain the same. That's independent, but also it's not changing. It's always 4 out of 52 because there's 4 aces. So this is a binomial setting. Since I know that this is a binomial setting, what does that allow me to do? Well, it allows me to do all those calculations we did yesterday if I wanted to. I could not use a binomial CDF or a binomial PDF, what we have written on the board in our notes from yesterday. I can't do any of that if it does not meet these requirements. So that's the point of assessing whether something is a binomial or not, a binomial random variable or not. Let's do the next one. So on this one we have bins again. So anytime you're assessing, is it binomial? Write this out. You go one at a time. All right. Choose students at random from your class. Let y equal the number who are over 6 feet tall. Let's go ahead and start with, yeah. Somebody's at the door. Okay. Oh, yeah, I did. Let me unblock. Sorry.
Thanks.
That's crazy. You know, your teacher can actually remove you from that.
Huh?
Your teacher can remove you from that.
I'm going to take your A class right now. So.
Oh, well, they should still be able to do it. Let me end monitoring. No problem. It's going to be a fun video for Bennett. Okay. All right. I lost all my stuff. Dang it. All right, so bins. The first person that's doing this is, let's just have Daryl do it. Daryl, is it binary? How do you know? Yeah, they're either over 6 feet or they're not. So there is an element of success. There's yes, no. There's failure or success, failure. Good. Is this an independent process on this one? So let's see. Let's just go with Sophia. Is this independent? What's happening? Okay. Imagine doing it in here. If I pick one person, does that change? If I pick somebody who's over 6 foot tall, Eldrin, you are, right? So if I pick him, does that change the probability of getting someone over 6 foot tall afterwards? Am I putting him back?
Oh, no.
That's important. As soon as I take Elgin out of the population here, this group of people, it becomes, because I don't think anybody else is over 6 foot, it becomes 0, right? So knowing that he's already been chosen does change the probability. So it's not independent. There's not even a set number of trials. I'm going to go ahead and answer in. No, there's not. They don't tell us how many people we're picking. The probability of success is changing because we're not placing them back, okay? So there we go. All right, next. Let's do it on this last one here. This is an interesting one. So you roll a fair die 100 times. Sometime during the 100 rolls, one corner of the die chips off. Let W equal the number of 5s you roll. Okay, let W equal the number of 5s that you roll. So, let's see. We'll go ahead and Addie, is this binary?
Yeah.
How do you know?
You either get a 5 or you don't.
Correct. Okay, you get a 5 or you don't. Next, independent. Let's go with Elgin.
No.
Why?
Because when you roll it, the corner chips off, so it isn't fair.
Okay, so let's. What is that? Is that enough to say it's not independent? Is my question.
That one is the probability of success. Oh, that's the success.
Is it just the S one that's violated? Because I'm not saying you're wrong. I just want us to think a little bit. Like, because I'm sure that there are other. We might be split here on this. And this is what makes this one so interesting. If we had a 10-sided die or if I had a coin and a 6-sided die, are those independent? They would be. Okay. The probabilities are different on them, so they couldn't be binomial. They would. If I had a coin and then a die, I could not do binomial. Okay, because S would be violated. In this situation, we're rolling. At some point, we could have rolled it 50 times. Then the corner chips off. So what we're saying about independence is knowing what happened before. So if I got a 5 before, does that change the probability of the next one? It doesn't usually, but then that corner chips off. But that's not because we knew the prior result, okay? Independence is, I know what has happened, what's happened before, that's going to change the probability of the next thing. So independence is actually okay on this one, all right? Independence is okay on this one. Is there a set number of trials, Braden? Yeah, there's 100 rolls. And then Elgin had already said this, it does violate S here because at some point that probability ends up changing, and so we cannot we can't use the binomial calculator. We could not use binomial CDF because eventually that probability does change, and so it's not accurate anymore. It doesn't work. It's almost like saying, what if the pegs at the bottom row of that had a default bias to go to the right at the end? Okay, then it would be much more difficult to get an accurate calculation just from, it wouldn't be difficult. It could be done by a computer pretty easily. But at that point, it's not a binomial model. So the Plinko that we did, that's all about every single peg has a 50-50 either way. I want to do this with we don't want this one. We talked about that yesterday. Okay, so what you guys are going to do is I would like you on your page somewhere you can go like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You guys are going to take a quiz. But guess what? There's no questions. You have to guess. Will you pass this? That's the question, right? Will you be able to pass this quiz? So it's pretty easy. You guys just got to figure out what the key will be. Huh?
Should this go in my notes or can I open it?
It doesn't, like, I want the result to go in your notes. We can actually in our notes put guessing on a assessment. Of course, this will be of interest, I think, just as much as the Plinko odds. We've learned a lot. Somebody left me a sign over there. Who did that? But said Mr. Woods is the best gambler. So it's false propaganda. They aren't paying attention. So you're going to guess on this, and then I will reveal the answers on the next slide. You'll grade yourself, but just go ahead and fill that in. Who's cheating?
I'm not cheating, right?
How could he cheat? The next slide has the answers.
I didn't know.
Do you guys think that, like when teachers make a test, they intentionally won't like repeat letters?
No, they always
They do it all the time.
it's 3 or more.
Well, you'll do like half the test for like none, and then it'll be like 4 in another. And
Yeah.
it stresses me out.
Doesn't that like get in your head if it's that many letters in a row? All right, are y'all ready to grade your test? No? Okay. We're ready? Okay. Here we go. There's the answers. Please grade your test out of 10. I need to actually change these numbers here. Let's 6. You got a 60? You got 6 out of 10? You got none? Yeah. I think I've done this for many years now. I think I've had one student get 6 out of 10. So. Oh, it was 7. 7. Yeah, 7. Okay. All right. So, who has the highest score? Who has it? Who thinks they might have the highest score? What do you have?
I think 6.
You really do think you have 6? You can find out by grading it.
I just counted.
Okay. So you got 6 right.
I got 6 right.
Okay. Anybody beat that? So you passed,
Let's go.
right? You passed. And so we're going to ask that question. How likely was it? Because we did change our, like that's a D, but it is passing, right? Just from guessing. Not a lot of work there. You don't have to think too much. But is that what is typical for this scenario? That's what we want to ask now. So over to the side, I want you to start with next to this. So I guess this should go in your notes. Abby, sorry. You can put this first part. Is it a random variable? Is X a random variable? X is the number correct. You can just write bins next to that. That's what I'm going to do on here. So we'll write that again, bins. Okay. And we'll just go through our lineup again. Angel, is this binary? Yeah, let's make sure we define this. X equals number correct. How about that? So why would it be binary? Exactly. So it's correct, or you get it correct, or you don't. Are they independent of one another? Is the next question, Ethan?
Yes.
Yeah. And there's no what you put on the prior question, and you don't know the result if you got it right or wrong. You don't do them one at a time, but they should be independent of one another. For me, if I make a test, I think there is some bias that goes into it. So I think that subconsciously, if I'm making a test like A, B, C, D, E, sometimes what I put the past 3 does kind of influence what I want to put for the next. But that's so probably not best that I do that. I should probably do a random letter generator each time. That's probably what I should do. Okay. No, I'm sure y'all have had multiple on my tests where they've gone in a row. But I don't know if some of those tests I didn't make. So, but if I were making my own tests, sometimes I do avoid. But that's not true. I make all my sports stats tests, and sometimes you have repeats. So, but it is independent. Next, is there a set number of trials, Daryl? Yeah, how many? Yeah, it's 10 questions. It's trials. Is the probability of success the same throughout all of this, Abby? What's the probability? 0.5. So let's write this down. N equals 10. P equals, you said it was point what?
I said 1.
1 out of 5, 0.2. 0.2. Oops, that's bad. 0.2. And so what you guys are going to do is you're going to figure out these parts here. So first off, in your notes, you can put B and you can say probability that X equals 6. So we're saying what's the probability that you get 6 correct? That's what we want to know. Since we have proven that this is a binomial random variable, we can use those functions that we defined yesterday. Okay? Which one do you need to use for B? Is B a CDF or a PDF? It's a PDF. Yeah, it would be a PDF because it's exact. Notice, and I think that I need to write some more of this out, but PDF I put here is exact. You can think of that letter P as being precise. I don't know if that's actually what it means. I think it's just a probability density function is what it means to find one value, but it's precise, it's exact, if that helps you. And then a CDF is a range of values. A CDF is a range of values. But let's start here with B. You should be doing a binomial PDF. The trial should be 10. The probability is 0.2. And the successes are 6. Does everybody remember how to do that in the Inspire? Good. Sophia, did you get it?
Yeah, I got
What
0, 0, 5, 5, 0, 5.
Man, this is difficult to write on. How many zeros? 2 zeros, and then what?
5, 5, 0, 5.
That seems good. Okay. So that's the probability right there, 0.0055. So that's very unlikely what you did, Braden. Less than a 1% chance of actually happening. Okay? Now, so this is just the probability of getting the minimum score exactly. But then C is saying what's the probability that you pass from just guessing? Because you could have passed by getting 7 correct or 8 correct or 9 and obviously 10. You get all of them right, you get 100. But here we want to know what's the probability of just passing. That's what this next one is. So this right here is this a PDF or a CDF? This is a CDF. So that's what we're going to do on this one. Okay? This is a CDF. I am going to add some notes to this right here. This is what we had written yesterday, multiple events. So a lot of times with these CDFs, you have greater than. You may want to go back in your notes to look at this. Greater than. I don't know if there's a glare there. Hopefully you can see that. Greater than. At least. Less than. Or at most. Which one is part C asking us? Which one of those? This is at least 6. Pause this and go back and pause it if you need to write that down. We're going back to the main scene here. Okay. So we're back here. All right, so at least 6. So it's a CDF. So with the CDF, you have the, I'll write it up here. So binomial, oops. So binomial CDF. The first thing it wants, it's the number of trials. You have the probability. And then it asks for the lower. What's the lower here? 6. Upper is 10. Good. So there it is. That's the binomial CDF. Gianluca, what did you get for that? Good. Okay. And so you can see that that's just barely greater than this one. Okay. Then we have part D, which is less than 6. This would be less than. This is the less than symbol. So you're going to do another binomial CDF, but this time, what's the lower and upper boundaries to this? 0, is it not 6? Do I not include 6? Good, it's less than 6, so it's 5. Okay, This is the probability of getting 0 through 5. By the way, this is also going to be the complement of what we did on part C. So if you subtract this from 1, it should be that value. But go ahead and do the CDF for that. Addie, what did you get? Did you get that to work? On your own? Is she just looking off yours? Do you know how to do it in the Inspire?
Well, yeah, but then you said if I just subtract 1,
Oh.
C from 1.
Well, you could do that, but I should have said that later, huh? 0.8863. I think so, but unless I'm saying something wrong here. But what did you put? Did you do your lower boundary 0, upper boundary 5?
Oh, I did 1.
Okay. Well, we do. The reason we include 0 is because you could get none right. John-Luca, that's what you did, right? So we have to include the possibility of getting none right. Okay. You shouldn't feel bad. It was guessing. Okay. You should feel bad.
Yeah, I feel bad.
That's like when on ACT when people get really low scores, lower than what should happen if you guessed. It's like, But because that's a thing, by the way. 60 math questions. We'll get to that in a second. Anyway, did you get it fixed? 0.9936. That looks good. And those are complementary. If you add those, that gives you 1. Okay? But yeah, with the binomial CDF. So is it likely that you're going to pass while you guess? No, it's not. Okay? Now, we're going to add a note. I want to know what the expected value is for this scenario. In your notes, let's write this down. Let's see. So, got a transition here. Okay. Sorry, I got my OBS going on here. So in your notes, we want to talk about expected value and standard deviation for, let me put a star here by this, for binomial random variables. Okay. So the expected value for a binomial random variable is just this. It is n times p. That's it. This is in your formula sheet. I think I threw this at you at the end of class yesterday, and I didn't really give you time to let it sink in. But for our example here, so guessing, what is the expected amount that you should get correct on this test if this is the formula? What is n? 10. You're taking 10 questions. What's the probability of success? 0.2. So you should get, that's what should happen, okay? And that's why for a lot of, like, in an ACT environment, which I think, I guess Bennett is one of our only juniors. I don't know. No, Abby, you're a junior as well. You'll be taking your ACT soon. That's why they say that pick like whatever your goals are for ACT math or any of the ACT problems. Do the ones that you're most confident in. I think I've heard Harris say before, like pick the 40 that you feel the best about. Save 20 for later. Okay, focus most of the test on those 40. And then the other 20 gets the letter of the day, whatever it is, A, B, C, or D, or E. You just pick one and fill it out. Because if I guess on 20 of the questions on the ACT, how many do I expect to get right? You expect to get, well, it's not 1/4 because there's 5 choices for each one, I believe, unless I'm wrong about that. I think you would get 4 correct. And so you're just counting on probability to take care of that for you, okay? You're counting on the idea that it's independent random problems where that will work. Now, if you have time, obviously you can increase your odds by trying the questions. But for some people, that's a really good idea. Instead of 60 questions, full send it on 60, do 40 that you're the most confident about and just guess on the rest. Sometimes that's not bad, okay? That's not a good tactic for my class, okay? But I'm just saying for a big test like that, where you can take it multiple times and improve your score, that's a good idea. All right, let's do the standard deviation now, because not everybody got a 2. We see Braden, he got 6. We have somebody that got none. What should be typical? What should we see most of the time? On your formula sheet, this is N times P times Q. Q is the complement. Okay, it's the opposite of P, so it's 1 minus P. So I'm writing it like that so that you know. What was I talking about? I'm putting this out here so you know what that means in your formula sheet. Let's do our example here. What is the variation of what we should see within this? So we do square root of 10 times 0.2. What would be Q in this case? 0.8. It's the complement. Let's go ahead and type that in. Find the standard deviation for this. What do we get? 1.265. All right, so you go a deviation above 2, a deviation below 2. That's what we expect most people to be. Okay, that many questions correct. So anything outside of that, like 6, we already saw that the probability of getting 6 is pretty intense, like low. So we've talked about how if you're 2 deviations from the mean, a lot of times that means you're unusual. And so you can imagine that. If you go within 2 deviations of 2, that's 0 to 4-ish, right? A little bit more than 4. So that's typical, and you shouldn't feel bad if you guessed and you're between 0 and 4, or maybe 5 is pretty difficult. But like, look, 99% of the score should be less than 6, so that makes sense. Okay, so that's how we find the standard deviation and the mean for a binomial random variable. In your homework, or the My Open Math, you have several problems that talk about that. By the way, I went through there today. I was working with a student earlier today, and I realized that there's some content that we're not going to get into. So I did remove a couple questions. There's one with like a jackpot that requires algebra that I decided to take out as well. So things have gotten a little bit easier on that front. Okay. All right, so that is binomial random variables. Tomorrow, we're probably just going to practice. I've got a worksheet where you will determine if it is binomial, and you'll answer probability questions. It's an old quiz I used to give out, but I think that we'll just use it as practice. Okay, we'll just use it as practice to work through, and so we'll get better acquainted at realizing if it's binomial or the other one. We're about to get into another example, which is we're going to talk about a geometric random variable, which I think y'all are going to enjoy this because there's a game we're going to play where I'm going to be giving you guys points on the next test for free, bonus points. Okay? The next test, by the way, will be our midterm because we have to have a midterm in here, and every class has a midterm. And it's going to be all the content. I will have a study guide to give you guys to work through. But this content we're working on will be in that, so this will not have its own test. And because it is comprehensive, I want to give an opportunity for you guys to earn some points. So here's what I want you to do. Let's draw a line in our notes. And this is nearing the end of this unit, by the way. We're going to do a lot of practice in here. But let's title our notes. Draw a line, and then here we go. Geometric random variables. Okay, geometric random variables. So the only difference between a geometric and a binomial we're going to talk about that. Let's go ahead and write out the acronym for recognizing a geometric. Here's the acronym: BITS. Bits. The other one was bins. So the only thing that seems different is the T. B still stands for binary. I still stands for independent. T changes, but we'll go ahead and write this: success, probability, remains constant. I know it's different than how I wrote it last time, but it bothered me that it didn't start with an S since it has an S. Now let's talk about T. Normally for binomial, we have a set number of trials, but geometric is different. This is trials until first success. Okay? That's important. You're looking for the first time a success will happen, the likelihood of that. For instance, if we went and shot free throws, what's the likelihood, or how long would it take for you to make your first one if we went out and did that? Does there exist a probability? And we would say, okay, even if you're an 80% shooter, you could miss that first free throw. So what's the odds of you not making the first one until maybe the seventh? Probably pretty low. If you're an 80% shooter, you should probably make that first shot pretty soon. But what we're going to be doing, we're going to be playing a game. This game is called the Unlucky Day, even though I am going to be giving out some points for this. Okay, so here's our example: the unlucky day. We'll write some more in a second on that. Okay, we'll write some more in a moment for that. But let's go ahead and I'm going to pull up a spinner. We got to get the wheel involved with this. Hold on, spinner, picker wheel. Here it is. Okay. And so here's what's going to happen. I am going to type in every day of the week. So Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay, so here's what's going to happen. I'm going to allow 3 different people to do this. Here's what's going to happen. You will say a day of the week, I will spin the wheel. If it does not land on that day, the entire class will get half a bonus point for the midterm, okay? And it adds up. So you can say, do you want to spin again? You can keep going. Everybody is represented by how you perform with this, okay? Now, you can press your luck. So as soon as the unlucky day hits, like if you say, I want to keep going, as soon as the unlucky day hits, it wipes all your points out. But if you get to a certain point, you can say, I want to stop here. The next person can go, or if you're the last person, you can just take your points. You can take the money and leave. But as soon as the day that you say, that's the unlucky day, by the way, as soon as that matches what I spin up here, all your points are gone. Okay, and you don't get those for the midterm. Okay, this is not gambling, by the way. It's not. All right, it's a game show. Yes. You can pick the same day. Like if you said, so for instance, if I'm a student and I say, hey, what day do you want? I'll say Monday, so I spin it. Okay. Probably going to slow this down or speed this up. I already lost. Okay, I already lost. I mean. But what's the odds of that happening? 1 out of 7. Right. That's 8 seconds too long. We'll go with 5 seconds. Okay. So that's just unlucky for me, right? But then, so if I do it again, I say Sunday. I'm the next student. There's a half point. How about that? Then I can say, do you want to keep going? You say yes or no, and you pick the next day. I can pick Sunday again. Okay, that's a point. Okay, and you just keep going. All right. And then if I keep going and eventually get it wrong, it wipes out all the progress. The next person would have to go. Who's feeling up to this today? Who's feeling lucky you want to get your class points on the next test? You ready? I'm gonna speed this up just a little bit more. Are you doing it, Ethan?
I guess.
All right. I'll keep a tally of the points. Which day would you like?
Monday.
Okay, Monday. All right, it's Thursday. There you go. That's half a point for your class on the midterm. How about that? All right, you gonna keep going?
Yeah.
Okay, go ahead.
Wednesday.
Wednesday. All right, there's a point. That's a whole point now. There you go. It adds up. I know some people want to get those averages up. A little cushion. Are you gonna keep going?
Yeah.
All right, what do you got?
Tuesday.
You said Tuesday. Okay. Doing so good. Doing so good. All right.
Okay. Friday.
All right. Friday, he says. Okay. He is. Got 4. That's 2 whole points. You didn't even have to work for it. It's right there. Going again.
Yeah.
Okay.
Thursday.
I'm sorry, what day?
Thursday.
Thursday. There we go. 5 in a row. That's 2.5 free points.
Saturday.
He's going again. Saturday, he said. Wow. It's the easiest bonus points y'all have ever had to do, right? You're gonna keep that's 3 points. So you can lock it in for the class, let somebody else go, and it stays there, or you can keep going. But if you hit the unlucky day, it's just all your progress is gone.
You did this for 3 students?
Yes.
3 students, keep going, right?
No.
Just do
I
it.
need
Just
these
do it.
so bad.
3 points. You also get 4 points for it being the dual credit, by the
See, why do
way.
you get 4 extra points?
So be the cherry on top.
Alright, you're outvoted. Sunday.
Here we go. All right. All right, you're at 3.5 points.
Go for the 5. Go for the 5.
Alright. Wednesday. Friday.
Friday. Okay. Good. So that's 4 points, right?
Saturday.
Saturday. Okay. Wow. All these points I'm giving away. So that's 4.5 points. You gonna do another?
Tuesday.
Tuesday. Here we go. Oh, okay. All right. That's 5 points. Well done, sir.
Alright, that's it.
You're locking it in. All right. So guaranteed at this point, you guys get 5 points.
The next person cannot lose those 5, right?
No. Yeah. So that's your safety net now. So you can just go past that. Really well done. Actually, probably one of the better starts in all my years of doing this. So very good job.
I'm a good gambler.
I guess so. This is you're the rule, right? Not the exception. All right. Who's feeling like they can maybe do possibly better?
I'm trying.
Braden's trying. All right, Braden. I'm resetting this. It's your turn. Here we go. No failures yet. This is wild. All right. Thursday. Okay, that's 1. Next. Monday. Okay. What's next?
Sunday.
Sunday. I should have made him do what if. Sorry. I don't remember what day you said.
I said Sunday.
Okay, all right. I'll have to take your word for it. I need to pay attention. All right, what's your next day? Saturday. Man, y'all are. I swear, usually people fail. All right,
Tuesday.
Tuesday. Okay, next. Monday. By the way, these don't add on or anything. You're just trying to beat. You're not getting in. It's not adding on. No. You're trying to pass. It's whoever gets the highest. Yeah. Yeah.
Sunday.
Sunday's next.
So we're guaranteed our 5
Your 5 are happening.
Oh, okay.
But if he can get more, yeah, we're trying to go further. You said Sunday? All right. Oh my goodness. Okay.
Tuesday.
Okay.
Thursday.
Thursday. Okay. Wednesday. And this will for the tie here, right? Okay. Thursday. I'm overwhelmed by this. This is really good. Friday. I promise you, I've had kids lose in 3 tries.
Saturday.
Saturday. All right, so you're at, that's 6.5. No, 5.5.
Go for 3 more.
6.5.
3 more. Yeah.
It's a lot of points for free, right? All right, what's up?
Monday.
So this is 7 points.
Tuesday.
7 free points. Imagine the whole, and I promise you, you said what? Okay. I keep getting distracted and not paying attention. I need to not do that. Like we'll keep, like I don't care. Like if it were 30, I would do it. I would honor any of it. Okay. If it were literally 100, I would honor that. By the way, I'm not kidding. So.
Go for one more. Go for one more so we have the guarantee points.
Yeah, so we have 8.
Try to go as high as possible.
My 0 out of 10 is not like these guaranteed.
This is 7.5.
One more.
Yeah,
So it'll be
you're
8
right.
points.
And
Yeah.
then the next person will be 8.
Yeah. Oh wait, yes. Thursday.
Wow. So you had gotten to 10, you got to 15, but it struck out. So okay.
Y'all know whose fault it is.
It's not gambling. Okay, y'all didn't risk anything. All right. Who wants to go? Third person.
Me,
All right, Addie. Earn these points.
Saturday.
Saturday. Okay. Off to a good start. Next. Tuesday. Okay. Good. Thursday. Okay. Saturday. Okay. Saturday. Okay. Killing it. Sunday. Okay. Wednesday. Wow. Okay. Wednesday. Okay. Just killing it. All right. Tuesday. Ooh, I thought that said Tuesday. All right.
Sunday.
All right, you're tied now with what Ethan had done. So everything moving forward. Now you got to make the choices.
Friday.
Friday. Okay. It's 1 extra point.
Friday again.
Friday again.
Just tell me what's the stop for me.
Whew. Oh man.
You got to stop 16 points.
Friday again.
Friday.
We're not 16 points.
Okay, Friday again. Here we go. Oh.
Guys, you told me Friday.
Good job, Ethan. You got 5.
I didn't want you to
Just
be
get one more. Just get one more.
You go for 8. Oh boy. All right. Well, there you go. We found the game. I'm interested to let's talk about first off the scenario here. Okay. Oh, yeah, see my OBS. Oh, let me pull that back up. Okay. For this unlucky day, let's start with our acronym bits. Okay. So the first question is it binary, and why? Why are you shaking your head? Yes.
Because it's either that you beat or not.
That's right. You pick the day or you don't. Okay. And so there we are. All right. Next, independent. Is each spin independent of the last? Yeah, it should be. It's random numbers, random seed that's happening within this. Those numbers are generated independently of each other. T, trials until first success. Well, that's misleading. It's really the success here would be you guys getting the unlucky day. So from my point of view, as far as someone who's not trying to give away a ton of points, really, I'm trying to know when is the first time you're going to hit the unlucky day. That's what I want to know. What's the likelihood of getting to 15 or 10, right? Like, what are the odds? Do you feel like this is pretty likely to happen? Okay, that's what we want to talk about. So, we have trials until the unlucky day happens. Is the probability the same throughout? Yeah, it's 1/7 that you're going to hit that unlucky day. Okay, so we're going to build a probability model for this to show what's actually happening here. So we have our random variable x, which is the trials until the first unlucky day. Okay, the trials until the first unlucky day, and that's what makes this a geometric. And on a problem, when you're reading a test question or a homework question, that's what you want to look at. You want to look and read it. Okay, is this a set number of trials, binomial, or is this a geometric where it's trials until the thing happens for the first time? Okay, and that's what makes it geometric. So we're going to write up our probabilities. We have x and the probability of x. What's the lowest value that this could be? Can it be, so 0?
One trial.
Yeah, because if I don't spin the wheel, then I can't get the unlucky day, right? So geometric, by the way, never starts at 0. However, binomial does start at 0. Like with the test, you could get no questions correct, the guessing on the test that we just did. So this is 1. Like on the first spin, that happened to me, right? I was giving an example, and on the first spin, I got the unlucky day. What's the odds of that?
1/7.
Yeah, I think that makes sense. You have a 1 out of 7 chance of that happening. Sure. Let's widen this out for the second one. In order to get to the second trial, what has to happen? You have to get past this. What's the odds that I get past one trial?
1/7.
Well, 1/7 that's the probability that you don't get past it. 6/7. And then what's the problem? So on the first trial, you guess one of the other 6 days shows up. Then what's the odds on the second trial?
1/7.
It's 1/7. Okay? What's actually happening here is a tree diagram. I'll draw it out here to the side. So we have a tree diagram. You have success or failure. Success or failure. Success or failure. And this is what this ends up looking like. Failure here is 1/7. This is 6/7. If I made it past the first trial, the probability that I fail on this one is this, then this. Okay, this is 1 trial, 2 trials. If I want to do 3, what would have to happen? Well, I'd have to not guess the day, and then guess the wrong, it would be the unlucky day. So it's 6/7 times 6/7 times 1/7. Yes, you can. And that's what we're moving. We're moving towards a formula. Yesterday we saw that super complicated looking formula. I said, hey guys, don't worry about this. Like, you don't need to memorize this. But we are going to do another formula for this. It's much simpler actually. Okay? So for 4, it would be how many? It'd be 3 of these. So 6/7 to the 3rd times 1/7. Because I'd have to have success, or the lucky days, lucky day, and then it would fail. I would get an unlucky day. Okay? And so this is how that looks. And so as we scale this up, by the way, does this ever end? Could you have gotten to 100? You could have. This just keeps going, and this number just keeps going up. What we see is a formula for the geometric probability. So it's the probability. So the probability of x is equal to the complement. I'll write it this way: q to the x minus 1 times p. That's all it is. Notice how on these 2 minus 1 is 1, so it's this to the first power here. Okay, that's the first power. This is 4 minus 1, so it's the 3rd power. So we're seeing this pattern happen. Do you need to know this formula? Not really. Okay? But let's go ahead and try this. Grab your Inspire, and let's try this. I'm going to use a TI, I'm going to use Desmos for this. But you can do this in your Inspire. Okay. Let's figure out what was the odds that the first time the unlucky day happened was on the, because it was on the, no, we didn't figure out yours, did we? But let's just figure out, okay, what's the odds that the time, if Ethan did it again, what's the odds that that would be the point at which he would get his first unlucky day? So what we do is, we do 6 out of 7. What's the exponent going to be? We want the 11th trial, right? Because you did 10 successfully, got 5 points. So if you had kept going, what's the odds that it was going to be on the 11th? So we do x minus 1. So it's 10, and then times, we have the probability of success, 1/7, or the probability of getting the unlucky day. So there's your odds. So there was a 3% chance that that was the first time you were going to see that. Now, by the way, 1/7, the most likely thing to happen is actually failing on this one. Like the first trial's there. If we do 6/7 times 1/7, it goes 12%. And you'll notice what's happening here is it's decaying. If I do, let me copy this down. And we'll change some of these values. So if I do, let's do the second, it gets smaller. Paste again. The third. Okay? And what we could actually do is, I could actually graph this. Let me go to Desmos. You'll notice that if you remember anything from your math classes, maybe not, this looks like a we call it geometric. This looks like an exponential decay function. Do you remember a times b to the x from that? Maybe not, but it looks like an exponential function. This is a decay, right? It's less than 1, so it's going down. This is the initial amount right there. That's your initial value that's happening. And so we can actually graph this and see what's happening. Not the scientific, hold on. Graphing. If I do, let's do let's just write it this way, 6/7 to the x, and then we do times 1/7, okay? And I'm going to include the table here, and so we can see our table of values on here, and I'm going to zoom in. Ugh. This is what it looks like right here. This is a probability density function. This is what's happening. So at 1, if I go 1 trial, it's right there. This is the probability of this. Did I do that wrong? Oh, it's x minus 1, isn't it? I messed up. Hold on. I forgot that. No. Okay. Okay, so look at this. Okay, so at 1, this is the value. At 2, 3, 4, these are the x values are the number of trials, by the way. I can get all these to show, but it's going down, and you'll notice that the probability of it gets closer and closer to 0, but not practically impossible. If I go all the way out here to 100, here's 100. There's still a little bit of area in here. It's not much. I can get, good grief. Never mind, it's too small. I'm not going to be able to zoom in. But this is displaying that probability distribution. So then we could ask the question like this. What's the likelihood that you should have failed before the 10th trial? Well, guess what? It's all of this area from here to the left. It's shaded. It's a density curve. Okay? So I want to know what this area is from here. Okay? We'll say at or before, I guess it would be from here to here, right? You can't technically include this because it's from 1 to 10, and we'll include that. Okay? So that shaded region right there, which I'm sure if I wanted to, it does once I go down that. So we want to figure out that area. Here's how we do it on the Inspire, okay? And we're going to see a couple cool things on the Inspire with this. Make sure I've got my display. Okay, so we're going to do, I don't need to erase that. 5 points, we'll remember it. Okay, so geometric density functions. In, I'll just say TI Inspire. Okay, so the first thing you have is the geometric geometric PDF, probability density function. To get there, go ahead and grab your calculators. And we're going to practice. We're going to try to calculate the probability that the first, we're going to try 6. What's the probability that it'll happen exactly on the 6th trial within this? But you go to menu, distributions, or sorry, probability. Distributions. and then you'll scroll all the way down to, let's see what it looks like here. It's it's letter F on mine, geometric PDF. Okay, so example, find the probability that x equals 6. Okay, we know that, so if you click on geometric P, did everybody find that? I'm not displaying it up here right now, but look at what it asks for. Probability of success and x value. That's way easier. There's not a set number of trials, right? There's not a set number of trials. It's not binomial. It's asking for probability of success. So P is 1/7. Let's type that in there, 1 out of 7. And then the x value equals 6. Okay? Put 6 in there. Hit enter. I got 0.066095. Okay? So if I click on Desmos, okay, on Desmos there, 6, it's right here. There's that value. We just calculated that. It's right here. If we had gone in our table, it would have been 6/7 to the 5th times 1/7. That's what it would have been. And so we got that. Now, put next to this exact. So it's saying what's the odds that exactly on the 6th trial we would get the first, that'd be the first time that we spin and get the unlucky day. So it has to pass all the others and then get to that one. So that's how I have to think about this. Next, the second thing that we look at is the geometric, I gotta change the geometric CDF. That's what we're looking at next. Oops. So the geometric CDF. C means cumulative. This is just probability density function. I said P, think about that as precise. So this would be, for a lot of these, you're going to see by the X try, after the X try, between is the other ones that you can see for the geometric CDF. That's just in the same menu. Follow the same steps. Menu, probability distributions, geometric CDF. So here's going to be our example. What's the probability that you would have the first day, the first time the unlucky day happens, be by the 10th trial, okay? By the 10th trial. So that means we're including the 10th trial as well as every other one. So it's all of this area that I've shaded on the screen underneath there. It's the sum of all that area, which is probably a decent amount. So it's probability that X is less than or equal to 10. So let's go to our binomial CDF calculator. So menu, probability, distributions, binomial or geometric CDF. Notice, okay, we put in 1/7. You'll notice that they put 1 in there. They don't put 0. You don't want to use 0 for this. It always, for geometric, it starts at 1. That's why they have that there. And the upper boundary is 10. Okay? All right, did y'all get 0.7859? Okay, so 0.7859. That was the odds. So you had almost an 80% chance to fail within that. Okay? Here's the question. What's the probability that you fail after 7 tries? Okay? After 7 tries. So we're going to say probability that X is greater than 7. That's what we want to know. So let's do the geometric PDF or CDF again. Menu, probability distributions, CDF. Probability of success is 1/7 again. What's the lower boundary? 7. What's the upper boundary?
9E999.
Infinity. Yeah. This graph, by the way, never ends. This goes on for infinity. Now, if you put like 100,000 in here, you'd be okay. You could just put a really big number because it's practically zero once you get out that far. It's almost impossible that that's going to be the first time that you fail. Okay, so let's do 9E99 infinity, and so after 7 is the 0.3966. So there's a 40% chance that afterwards you have your first failure be at that point. Now, what I was wondering when I was building this game was, well, how many points am I going to have to give away? What's the expected number of points that I'm going to have to give away for this? Because I obviously didn't want to give you too many, right? Imagine what if I had made it a point every day, right? We'd be at 10 points, okay? And I had to decide how many points I wanted to give away. So it started with, well, how many am I comfortably just giving away for free? Well, I needed to figure out how many times I would expect you guys to, how many trials I would expect you to get through. What is the expected number of trials it's going to take before you guys guess the wrong day? So we have the expected value and standard deviation for geometric. So it's a super easy formula. I don't know if it's in your formula sheet, but we have the expected value or the mean. You see them in a lot of different formations in this chapter, by the way. It's 1 divided by p. That's it. That's all it is. 1 divided by the probability of that event. So, example, unlucky day. P was 1/7, so the mean of that is 1 over 1/7. Keep change flip. 1 divided by 1/7, 7. That is what should have happened. So, Braden, you went really far. It must be your lucky day today. Or is that just sort of how you roll? Are you always lucky?
Always.
That's cool. See, I'm not. That's why I don't gamble.
I get that vibe.
From me.
Somebody thought you were the best. Somebody thought you were
Yeah, I don't.
Supposed to be the best.
It's crazy.
Huh?
Supposed to be the best.
The
Not
best.
just good.
Yeah, because I don't do it. I'm the best because I don't do it. The wisest. There's this. That's how you get the expected value. So when I designed this, it's like 7 points. That seems like a lot to just be given out. Let's make them work for it. Let's make them struggle for it a little bit more. Let's make them sweat. And so I said, okay, let's half this to, it's half a point. So I was expecting to give away half of this. All right, based on that. And if we did something where you had to pick, we just change it to anything. We roll a die. You expect the first time, if I want to roll a die till I get a 6, you expect to have to do that 6 times. If I want to flip a coin to get a heads, you expect to have to do that 2 times. Okay, that's what this is. That's what we're talking about here. We also have standard deviation. Standard deviation is an interesting formula here. So the formula for standard deviation is square root of Q over P. Square root of Q over P. Q is 1 minus P. So we take this standard deviation. It's square root of 6/7 over 1/7. That's what the standard deviation would end up being. There's a lot to type in your Inspire, but it can be easily done in there. But let me do this in here. So square root. Let's make a fraction. Let's make another fraction. 6 over 7 1/7. You don't want to calculate? Oh, I zoomed in. All right, there's the value. So the standard deviation is 2.45. So give or take that, which that's kind of what happened with 10 successes, but that's still pretty good. So you can go pretty extreme. I think I had students one year, actually no, it was last year. Riley Davis did, I think she got 15 points.
Wow, that's crazy.
It just didn't stop. So a lot of points in the AP stats. So all right, that is kind of the end of the unit there. That's all of the content that we're going to be assessing over. So for the remainder of class, we can, which we don't have much time, but you can start working through my open math. Tomorrow we're going to do a little worksheet. Let's see when that is. It says the 29th, but yeah, we're going to probably test. I want to spend a couple more days before we take our midterm. We will, let's test Tuesday. Even better, right? Dang it, you're right. No, it's a something. It's election day or something. All right, we'll do. No, that's the 12th. So let's do the 6th. The 6th is when we'll do that. So I'm going to go ahead and I'll change this to be due. Make the assignment due tonight. Madman.
But then we have to play the gambling game again, and if we get 10 more days of
You're calling the game we just played gambling?
yeah,
How so? Why?
we're gambling our points.
But they're actually given to you.
They're gambling our points just like whenever you play. Yeah,
But they're not yours until you finish the game. So you're not really.
You just don't want it to
They're-
be gambling.
You didn't risk anything. You started with nothing. You put nothing in.
But we have the opportunity to bank something that we are.
All right, I'm stopping this video.